So welcome to my YouTube channel Razacat, and today we will see in the wave motion topic that what is the concept of power transmitted along the string. Okay, so in the wave motion topic we'll see what is the concept for power transmission. Okay, along the string by a sine wave. Okay, so suppose that there is particular sine any wave. This is like this. Okay, so this will be called as a sine wave. Okay, because it is a sine function. Sine function. Okay, and if the function is this cos function, we can call it as a cos wave. Okay, because it is a cos function. So generally in the standard things we will keep it as a sine wave. Okay, in the standard cases we take it as a sine wave, but if the it is like a cos, so it will be a cos wave. Okay, so suppose that how it is generated. So suppose that there was a man. Okay, from here. Okay, and it is here fixed. Okay, this string is fixed. This is like this. Okay, this is a rope. Okay, and man started swinging the string. Okay, swinging the string. So if the man started swinging the string, so what will be there? It a sine wave will be generated. Okay, if man started swinging the string, so a sine wave will be generated. Okay, so what power this man is giving to the this point? What power is given by man? Okay, so if power is given by man, okay, so if power is given by man, and since string is not fixed, okay, so the power will be transmitted along the string. Okay, so suppose that the string was like this and the man was here, so the string will start swinging, and this power which man here it gives, this was man, this power given by this man, the it will be transmitted in this whole string, here, all string will have power. Okay, now, or energy. So how here the power is defined? Power here is the energy in the string. So the power supplied by man is now energy in string. Okay, so this is how the it is defined the power. So now I think you have got the concept of power. Okay, so suppose, so the how the general equation of the string is defined, so the or the wave is defined, the general equation of wave. So the how the general equation of wave is defined, so y is equals to a sine omega t minus x by v. Okay, so this you have to remember. Okay, so that y is equals to a sine omega t minus x by v. This is the equation of sine wave. Okay, and this is the standard equation. Okay, this we have to remember. Okay, so this is very important, that this equation we have to remember. Y is equals to a sine t minus x by v. Okay, this omega is the angular frequency, t is the time, x is the x displacement, and v is the velocity, and a is the amplitude. Okay, and y is the y direction. Okay, so writing one more time, y is equals to a sine omega t minus x by v. So here omega is nothing else but angular frequency. omega is equals to 2 pi f. Okay, a is the amplitude, t is time period, time, okay, and x is the x x position or the horizontal position, and this is the vertical position of a particle in a string. Okay, so this is how it is defined, and v is here the velocity of the particle or the string. Okay, so this is how different parameters in a particular sine wave is defined. Okay, okay, and this is how the equation of the wave is defined. Y is equals to a sine omega t minus x by v. Okay, so if representation, so suppose that this is the equation, this is the sine wave, and this small portion we have taken, small portion. Okay, so how it will be there, suppose that it is like this small portion, and suppose that this is the force F, and this is the angle theta, and this is the x position, and this is x, and this is y. Okay, so this is the representation for this. Okay, so like this we can if we take the portion of a particular string, we can clearly see how it can be depicted like this. Okay, so this is a force F, and this which is making an angle of theta with the x-axis. Okay, and the force F is making an angle theta, and this is the x-axis, and this is the y-axis which is there. Okay, so how this f5 will be given? Okay, so the f5 will be minus of f sine theta. Okay, and the which is, if the angle is very small, sine theta can be written as tan theta. Okay, so how this, suppose that this is now x, this is theta, and so this is f, so this is f cos theta, and this is f sine theta. So what is fy? Fy is f sine theta. Okay, and if angle is small, theta is small, this is the math property that sine theta is tan theta. Okay, so perpendicular upon hypotenuse is perpendicular upon base if theta is small. Okay, so how this is there, we can clearly see this concept that if angle is small, sine theta is equal to tan theta. Okay, so suppose that this is the particular triangle in which it is there, so this is hypotenuse, this is perpendicular, this is base, and this is theta. So if tan theta is what? Perpendicular upon base, and sine theta is what? Perpendicular upon hypotenuse. So if theta is very small, so this hypotenuse will tend here, tend here, tend here, this theta is small, so what will happen? This is like this. Okay, so perpendicular theta, again if theta is small, so what will happen? It will be like this, perpendicular upon hypotenuse, base. Okay, so this hypotenuse will become base, so hypotenuse will tend to base. Okay, so if theta is small, sine theta will be equal to tan theta. So this is the thing which we have to remember. Okay, so this is very important thing which we have to remember. If the theta is small, hypotenuse will tend to form a base, and sine theta will be equal to tan theta. Okay, so this is the thing which we have to remember for this. Okay, so fy is equal to f sine theta minus of f sine theta. Since the force was like this and theta was like this, so f sine theta will be here, so minus of f sine theta, which is f tan theta, minus of tan theta, or minus of f dy by dx. Okay, so how this power is defined? So power is defined as power is equals to minus of f dy by dx into dy by dt. Okay, so this is how the power is defined. Okay, so power is nothing else but force into velocity. So dy by dt is nothing else but velocity, and this is nothing else but force. Okay, so force into velocity is the power. Okay, power is equals to force into velocity. This formula also we have to remember. Force into velocity. Power is force into velocity, and here power is equal to minus f dy by dx into dy by dt. Okay, so this is how the formula for the power will be defined. Power is equal to minus f dy by dx into dy by dt. Okay, so this we have to remember. Okay, so what was our y was a sine omega t minus x by v. Okay, so this was our y. So if we find what is our dy by dx and what is our dy by dx and what is our dy by dt, so we can clearly find from this equation what is our dy by dx if we differentiate in terms of x, and what is there if we differentiate in terms of y. Okay, so if we differentiate in terms of x, what we will get? We will get minus omega by v into a cos omega t minus x by v. Okay, so this is there when we differentiate in terms of x. Okay, and when we differentiate in terms of y, what we will get? We will get omega into a, okay, into cos into, okay, into omega into t minus x by v. Okay, sign will change into cos by the differentiation. Okay, what we got from the dy by dx? We got from the dy by dx this minus omega by v into a cos t minus x by v, a cos omega t minus x by v, and dy by dt. What we got? By dy by dt we got omega into a into cos, okay, t minus x by v. So this we got from from the dy by dt, and this we got from the dy by dx. Okay, so if we multiply these both and also by minus f, because power was minus f dy by dx into dy by dt. So this into this, okay, into this. So these three we have to multiply. Okay, so what we will get, we if we multiply minus f into omega square, okay, into a square by v into cos square, okay, t minus x by v cos square omega. Okay, so this we get. Okay, so minus f omega square a into a square by v, okay, cos omega minus omega t minus x by v into cos omega t minus x by v, so cos square omega t minus x by v. So this we will get. Okay, so like this we will proceed and we can do the question. So what our power, because power is equal to now omega square a square f upon v cos square omega t minus x by v. So this was our formula for the force which we become. So this is the power at which power or the rate at which energy from left hand side of man will be transferred to our right hand side. Okay, so suppose that this was the man which was holding the string. So this is the rate at which the power will be transferred from here to here to here to here. This is the rate of energy transmission. This is the rate at which the energy will be transferred from left to the right. Okay, so suppose that since it is a cos function. Okay, so how the what was the formula of the force? Omega square a square f upon v cos square omega t minus x by v. Okay, so this was our formula for the rate of energy transmission. Okay, rate of energy transmission. So this was our formula for the rate of energy transmission. Okay, so for a one cycle, since this is a cos function or a periodic function, so that in a particular cycle, one cycle, the average value of a cos square function is 1 by 2. So p average will be given as 1 by 2 into omega square e square f by v. So this is the average power in a one cycle. Average rate of energy transmission in one cycle. Okay, so this is the energy transmission rate in a particular cycle or a one cycle. Okay, this is how the rate of energy transfer from left to right we can determine in a particular string. Okay, thank you.